I spend a lot of time working on projects here at my soldering workbench, but not everything that I work on can be brought here. It's no secret that I like working on big things, like my giant boxing robots or my large format laser cutter. And sometimes I build projects outside, like when I built the Wi-Fi weather station. When these projects come up, I get really frustrated because it's really impractical to gather all of these things and bring them to the project. The two things that anchor me to this workbench are my soldering iron and my fume extractor. Both of these things need to be plugged into a wall outlet. So the question is, how do I make this setup mobile? The soldering iron is simple. I just ordered this portable one from Digi-Key. It plugs into a USB-C powered battery bank. I just tested this out and it works great, so we can check that box. On the other hand, the fume extractor is a little bit more tricky. I couldn't find a portable fume extractor, and when I'm working on electronics, having a fume extractor is non-negotiable. My name is Zach and I'm the Byte Size Engineer. In this video, let's see if I can complete my mobile soldering setup by building a portable fume extractor. Before I dive in and start designing my own portable fume extractor, let's take a look at this one and see how it works. I can take off the carbon filter here, and I can see that there's just like a fan inside. And that looks an awful lot like a regular computer fan. On the back here, there's a little grill to protect your fingers from getting caught in there. But other than that, this looks pretty simple to build. So the first thing I need to do is figure out what size fan I need for my portable fume extractor. I looked through my stuff and I found this fan here. Now it runs on 12 volts, but look at the size of it. It's definitely not big enough. I need the fan to pull out all of those fumes, and I don't want to risk having a fan that is too small. So this one is not gonna work. I went on the Digi-Key website and I found a 120 millimeter fan that runs on 12 volts. This is much closer to the size in my desktop version. So I'm excited about this, and I think I'm gonna go ahead and use this fan. So the next thing I need is a carbon filter, and of course Digi-Key sells those as well. This one here fits perfectly on my 120 millimeter fan. I've got my two main components now, the fan and the filter. Now the challenge is, how do I power the fan and how do I enclose all of this so that it works as a portable fume extractor? There are a few different ways that I can go about this. I know that I definitely want to have this battery powered and have it rechargeable. So the first thing that comes to mind is using a LiPo battery. Let me go grab one real quick. This is a single cell LiPo battery, which means the voltage is 3.7 volts. That's not enough voltage to run this 12 volt fan, obviously, so I'd have to use some sort of boost converter, which is way more complex than I want it to be. So I'm not a fan of that solution. The next option is just to use a regular 9 volt battery. 9 volts should be enough to spin up the 12 volt fan, albeit at a slower RPM. So the only way to find out if this is gonna work is to solder on this battery clip. Now, I wish I could do it here, but I've got to bring this all the way over to my soldering workbench. Gosh, this is so inconvenient. You can't see this from all the way over there, but I'm just soldering on the positive lead to the positive terminal and the negative lead onto the negative terminal. That's done. I can turn off my fume extractor and give this a shot. So this is working pretty well. I can feel a lot of airflow moving, and if you were building one of these for yourself, this would be a totally viable option, but I'm not so certain about this solution either. One thing I don't like about it is that I'd have to get a rechargeable 9 volt battery, and anytime it runs out of juice, I'd need to pull it out and recharge it, which seems like way more hassle than I want. But I have one more idea that I think will work great, and it involves this thing. What is this thing? Let me go grab my drill and I'll show you. I've got my drill battery here, and this is an adapter that plugs into my drill battery, and I can plug things into this and run them straight off this battery, which is really cool because these batteries are readily available, they're easy to take off and charge anytime I need to. But there is one drawback, and it's that these drill batteries run on 18 volts. So let's plug it into the 12 volt fan and see what happens. Oh, there we go. Whoa, that's, as you can see, way more airflow. You know what? I just had a really cool project idea. What if I built like a little hovercraft using this? That might be an upcoming project. This is gonna suck a lot more air than that 9 volt battery, but I'm not sure I feel great about running this 12 volt fan on 18 volts for a long period of time. The solution to that is to use a buck converter. So I can plug the battery into this and it will reduce it down to 12 volts. And that would be a much safer and more reliable way to run this setup. Once again, this is a perfectly viable solution, but I did notice something about that portable soldering station that is going to make this whole project a heck of a lot easier. The iFixIt portable soldering station actually has two USB ports on it. one for the soldering iron, and one for me to apparently use for whatever I want. Let's see if I can power this 12-volt fan from the second USB-C port. So to do that, I've got myself a USB cable and a little USB-C breakout board. So let's plug this in and see if it works. Okay, the fan starts spinning up, but immediately I'm noticing that it's spinning at a much lower RPM than I would expect from 12 volts. And that's because the little USB-C breakout board that I'm using doesn't have any power delivery circuitry on it to request more than 5 volts. So I'm only getting 5 volts from the power supply, and that's why it's spinning much slower. So I've got a solution for that, and that's this little chip here. So this is a USB-C power delivery, or PD, breakout board. If you look at the edge of the board, there are some little pads that you can create solder bridges on, and that is what selects the voltage that you want. So I'm gonna go ahead and create a little solder bridge on the 12-volt pads, but I can't do it here. I'm gonna have to go all the way back over to my unportable fume extractor. Hang on a second, I'll be right back. Oh, forgot my solder. All right, we're back. So now I'll move the fan over to this board. When I plug this in, I should be getting 12 volts out of the power supply. That seems to be spinning at the same speed as the 5 volts. Let me get my multimeter and check what voltage we're getting. Oh, yep, sure enough, 4.99 volts. So there's something wrong going on here. It's not getting the 12 volts that I'm requesting. Let me try unplugging the soldering iron first. Did you hear that? The fan sped up once I unplugged the soldering iron, which is really interesting. Let's see if it's 12 volts now. Yeah, 12 volts. So there's something going on here with the order in which I plug in these devices. My guess is there's something going on with the USB-C power delivery spec in this unit here, and for some reason it's not giving me the 12 volts when I plug it in second. I know this is a brand new product. It's only been on the market like a month or two, so maybe they're already aware of that and they're working on the fix, but that's something interesting to note. So our workaround is pretty simple. All I need to do is plug in the fan first and then the soldering iron, which is probably a good idea anyway, because you want to have that fume extractor going first before you have your soldering iron on. So the next step is to put all of this into a case. We can't have all these wires going everywhere, obviously, so I'm going to jump on the computer and into my 3D modeling software and design a really nice looking case to bring all of this together. It would be really easy for me to design this as a separate unit and it just sits on the side of the soldering station, but I think that's really boring. My big idea is that I want this to be all one unit. So as I start placing these components, I have that in mind. The first thing I'm going to do is bring in a 3D model of the iFixIt soldering station, which is pretty cool that they even have that. So once I've got that in there, I'm going to bring in a 3D model of the fan, and I'm going to put it at 30 degrees. And then I've got a model of the USB-C power delivery board that I just showed you. So that's going to go on the bottom right there with the little USB-C jack sticking out the back. Now that I've got that in place, my main components are here, and I can start designing my 3D printed enclosure. So I'm going to sketch out the front of the fan, and I'm going to make these pieces kind of snap together, and I'll extrude that out. So this is what it looks like so far. And then I'm going to add in some hexagons and make like a grid of hexagons as the front grille of the fan. I really like that. I think that looks great. So next I need to extrude the back piece here, and I need to make sure I leave a little cutout spot for that USB-C board that we're putting in there. And then I can extrude the back piece here. And I also made sure to leave in some holes so I can screw it in from the back and secure that fan inside there. So this is looking really good so far. Now I need to figure out how I'm going to attach it to the hub itself. And this is where having a 3D model of the actual product comes in really handy. It's got some really beautiful designed curves in there, and it would be really hard to figure out what those are just by hand, but I can just project that onto my own sketch and then put a little bit of an offset so that my part mates beautifully with the existing product. So here's what that's gonna look like. As I was testing out this unit, I was a little bit annoyed that it doesn't come with a way to clean off my soldering tip. So I thought that I could design and print a little brass sponge holder that will go on the side. And it even has these little accessory knobs that you can connect things to. And I think it'd be really cool for my brass sponge holder to slide on and click into one of those little knobs. So I've got that on the side here, and I'll extrude this out. And then I'm gonna cut a flat face in there, and then I will use the shell command to kind of hollow things out. And that's where my brass sponge is gonna go, inside that hole. And then I need to kind of cut out a little bit of a keyhole on the side. So in order to see that, I'll go ahead and hide the hub, and I'll look at it from this angle here. We'll go ahead and cut that out. So that should slide on to the little nub on the side. And the next step is to just print this out and then assemble everything together. So let's go do that. I am really excited about this. The first thing I need to do is to solder the wires of the fan to that little breakout board. And you know what would be really convenient right now is to have a portable soldering station right here. So for one last time, I'm gonna head over to my non-portable, stationary, tethered to the wall, inconvenient soldering station. How's it going over there? I'll be right back. Oh man, of course I left the solder all the way over here. Probably need these too. All right, moment of truth. Let's assemble everything to see if it works. Okay, so I've got the board kind of clipped into those little standoffs, and you can see that the USB port is visible from the backside. I need to tuck these wires in so that they're out of the way as I put this in. It's gonna be a little tricky. Do I have some tweezers? That might help. Perfect. Okay, now from the back side, I can put this metal grill on. I got this metal grill to protect my fingers from the back side in case I become complacent and for some reason stick my fingers in there. They'll be protected. Okay, carbon filter goes on next, and then the front cover. Oh, perfect. Look at that. This is so good. Okay, let's pull this off just so it's out of the way. And I can slide this on from the front. Oh, do I have this? Yeah, that's right. Perfect. Cool. That's awesome. Okay, and then this is the little holder for the brass sponge. We'll just stuff that in there, and it locks onto the side here on this little blue nub. The soldering iron will come in on this side and clip in. And that's it. Okay, time to turn it on. That seems like it's working at the 12 volts just based on the sound of the fan. And then I can plug in soldering iron, and it's turned on as well. Cool. And it has a little LED indicator on the side telling me that it's heating up. And once it gets fully up to temperature, it should turn red. Perfect. This is really exciting. I've got a portable soldering station that has a fume extractor built into it. Let's give this a shot and see how well it works. This looks awesome. I'm really excited about having a portable fume extractor. Let's go take this thing on the road. I'm excited to use this portable soldering station with a fume extractor on my next project. I'm building a custom macro pad using this PCB, and I can't be bothered to walk all the way over to that workbench. Let's get started. The thing that made this whole project possible was that USB-C power delivery breakout board. It made it possible to use a 12-volt fan. In fact, that chip is very similar to the one that I used in this USB-C power delivery breadboard power supply, except this one has a couple more bells and whistles. If you haven't seen that video yet, check it out here on the Digi-Key YouTube channel.